All right, so I've seen many of you in a number of different venues over the last 2 days, and so I'm really excited to be here in a number of different capacities. As you know, I'm Karen Pearson, and I co-chair the Sustainability Council, and we are so excited to have had all of you on campus to discuss innovation and sustainability across all of the disciplines, so not just science, but art and business as well. So we really appreciate your engagement and continued engagement in this discussion, and we hope for many more discussions of this nature. So this afternoon I am here in the capacity of moderator for our lovely and esteemed panel of scientists, designers, and business leaders. So I'm going to briefly introduce them, but then I'm really going to let them introduce themselves and talk about their work and talk about how they found the ability through unique pathways for innovation and collaboration in the aspect of new materials, and in particular, in some cases, biomaterials. So we have Deborah Berger? Yes. Deborah Berger from Chargeurs, Gary Halada, who is from Stony Brook University, and Theanne Schiros, who is here from FIT. So thank you. So Deborah, would you please introduce yourself and tell us a little bit about your background and how you actually had the opportunity to work in this space of new materials and new fibers?
With pleasure. Good afternoon, everybody. I'm very honored to be here today to talk about innovation and sustainability. So I'm from France, Paris, and I work at Chargeurs, this is a little loud, isn't it?
Let's hold it further.
Okay, thanks. And so Chargeurs is a French company specialized in technical textiles, and I work in the wool business. So you're going to say, wool? Why is that a material of the future? It's been used for thousands of years by men, and it's definitely not a new material. But I'm going to talk about wool and blockchain technology. We developed at Chargeurs a eco-traceable wool label, which is called Organica Precious Fiber. And we decided to use blockchain technology to make it more traceable and transparent. And I'm going to explain to you how this works. What I think is also of interest maybe to some of the students in the audience is that I'm actually an outsider in the textile industry. I worked in finance for many years, and after having my second daughter, I needed more meaning to my career. And so I completely shifted careers, and I met the CEO of the Chargeurs group who talked to me about wool, and he told me that he thought that the wool division had a lot of potential and that we needed to develop it with new technologies and new concepts. And he's a great believer in sustainability. The Chargeurs Group is a signature of the UN Global Compact. And so he told me there's a lot to develop in terms of sustainability. Would you like to join? And I found the project absolutely amazing. And that's how I joined almost 2 years ago. And I've been very happy ever since. So this just to say that you can shift careers at any time and do something that makes more sense to you at any time. And I think I'm sort of an example. So what did we do with wool? We produce combed wool, which is the wool that you give to the spinner to make yarn. So it's the first step of wool processing after the shearing of the sheep. And what happened was that we were already working with a lot of ethical and responsible growers, but we were selling the wool at the commodity market level price. And the competition was becoming harder and harder, and we were dying, slowly dying. And we were thinking, but there's a lot of brands who want to buy sustainable and ethical wool, and they can't find it. So why don't we create a label and have it backed by technology? So that's what we did. We created our own internal label, which is Organica Precious Fiber, and we used all of the existing requirements from all the existing protocols and made it even better with other kinds of requirements. So we are RWS compliant. Some of you may know RWS. It's Responsible Wool Standard by Textile Exchange. And in addition to that, we brought social responsibility, meaning that there is, of course, no child labor allowed, that we respect a minimum wage for the workers, that we respect the workers' work condition and everything. And we added to that an extra layer, which is blockchain technology. I'm going to tell you a little bit more about that because I think that's the real innovative part of what we did. Our protocol is audited by a third party, which is called Control Union. And this is very important because, of course, we're not the ones auditing all our production chain. They audit our farmers, they audit our mills, they audit all the different parts of the chain. And we thought that's great, but that's not enough. We're making all this effort to work with very ethical growers, ethical workers. We have all those requirements to animal welfare, the environment, social responsibility. But people are getting a bit tired of the greenwashing, and they don't always believe that you did what you did because, of course, some brands can sometimes be a bit exaggerating their commitment. So we thought, how can we make it completely transparent and auditable by the final customer? And what is the easiest tool you have for technology-backed proof? It's your mobile phone, right? Everybody has a mobile phone. So we thought, how can we make it completely transparent? Which technology could help us? And that's how blockchain technology came up, because blockchain is completely unfalsifiable, and it's a technology that enables you to put a lot of data completely secured into a chain. What is very powerful with blockchain is that there are different steps into our blockchain, and each step is validated by two independent players. For instance, the delivery of wool from the farmer to the combing mill. Our system is going to send a text message to the farmer asking, did you send 5 tons of Organica precious fiber wool to the combing mill on X date? And then the system is going to send an email to the combing mill asking if they did receive the same quantity of wool on that exact date. And if both answer yes, then it validates one step of the blockchain and it moves on to the second step of the blockchain, which means that even if we wanted to hack the chain and enter all the false information, we couldn't, because it's based on so many independent players that we would have to hack the farmer's phone, hack the email of the combing mill representative, and so on. So it's completely impossible. And then all this information is presented to the final customer via an app, which is logged to the blockchain, and the final customer can see all the steps of the chain from the sheep to the shop, and they can see where the farm is located, they can see where the combing mill was, and they can access all the information on the audit certificates. So I very much believe that transparency is going to be the way forward in terms of sustainability. I think that today's customers, they accept that nobody's perfect and that they can understand that. But what they don't want is to be told lies or to be told false information. So we're not saying we're perfect. We still have a lot of things to improve. But through transparency, I think we're moving a little bit further for the whole system.
Excellent. Thank you so much. That was very interesting to hear how you could transform and collaborate along those steps. So Gary, would you tell us a little bit about the work you've been doing at Stony Brook and collaborations you've also had with FIT and the partnerships with actually design, so different disciplines as well?
I can just yell. You don't need this. When I teach my class, I wake everybody up. I'm in the Department of Material Science and Chemical Engineering. And so my philosophy approaching any type of research project is really the philosophy of material science, which is how you build that connection between structure, properties, performance, and processing. And so that's really very much what a lot of what we're talking about, concerns. How do you, what happens when you recycle a material? I was listening to the talk earlier today about how recycled, polymers become brittle or less strong, and so that can introduce microfibers into the environment. All these are very interesting questions to me because I approach everything in that way. And also, even what you were talking about with trying to trace the processing. We have a big cybersecurity effort. And one of the centers that I run right now is a center in additive manufacturing materials and processing. And one of the ideas is building in that sort of blockchain technology into the printing itself, so you can trace objects once they're printed. So all these things have good connections. But so kind of how I became sort of involved in these collaborations. I'm very interested in sort of building out collaborations with other institutions. I've worked with many other colleges on all sorts of projects in energy and environmental issues. I've been involved in Department of Energy work on hazardous waste remediation. So I've always had a strong environmental interest, as well as just the work that I do on the interaction of materials with the environment. My education, my background was in rust. I'm a rustologist. And corrosion is all about how things live with the world around them and how they change. I actually find corrosion very interesting. I've worked with an artist who studies corrosion and the changing materials, changing metals, how they slowly change with time and the environment, and where the artistic aspects of that are. And it's exciting to me to work with artists, for example. And when our dean, Fotis Soteropoulos in engineering out at Stony Brook, I think he made contact with the president of FIT, and they decided that let's start looking for ways that we can start to interact and collaborate. And we had a couple get-togethers, a couple meetings, and met people, and learned what each other did. And I'm very interested in this sort of stuff, so I try to get in the middle of it as much as I can. And so we started a very nice collaboration looking at recycling of cotton material, and in a green way. I mean, there's other ways you can recycle and break down the material that use very harsh chemicals, high temperatures, lots of water, all things you don't want to do necessarily. So can we find new ways using the tools of materials science and engineering? And I really like this project too, because I'm always looking at projects that get students excited. And a lot of the projects in engineering, well, I'm working on microstructure on printed steels. That's okay. Or I'm looking, let's go study dirt and rust. I spend all my time looking at dirt and rust. And, there's some students who really get into that. They find it very exciting. I worry about them. But to talk to them about something that has real societal impact. We talk about social justice, socially responsible design. At one point, I started a design award for socially responsible design for our senior design students. And where they won this fantastic piece of paper, I didn't have any funding, so that was what they won. That said they're socially responsible. But anyway, it was a very nice thing, and also enabled me to write nice recommendation letters for them when they went on to look at graduate programs. But in any case, in all aspects of kind of what we do as academics, and in a place like Stony Brook, I don't know how many of you have any of you ever been to Stony Brook University? Oh, tons of you. That's great. All right. I'm embarrassed. No, no, that's fantastic. And we work closely also with Brookhaven National Laboratory, which is right down the road from us. But it's a big research type university, and students who go there, if they just go there and study coursework and then try to hide and escape, they don't gain all the value of being at a university like that. So I try to get them involved in the research, and to have projects like this where there's a real impact on the world. That we've had people working on projects on microplastics that find their way into the environment. We have people working on I was mentioning before, there's students who developed a fabric to prevent the spread of bed bugs and things like that. So anything that has something that you can hook to the news or to some real, very important real world application really helps me get students involved. And it's part of my interest in an area referred to usually as value-sensitive design. And I teach value-sensitive design, the idea that anything that you see in the world around you, chairs and tables and floors and clothes and everything else, has embedded within it not just materials and physics and chemistry and technology, but also has the values of the people who made it and designed it. And so the question is, how can we introduce more positive values into the design of things? And I try to bring that to students throughout our traditional engineering disciplines, and I find that to be very important. And just last thing I'll say about that as well is, if there are students here who would like to come out, learn a little bit more about what we do, this is not a recruitment spiel. This is just, come out for a week, a day. If you want to learn a little bit about the technologies, I use surface science technologies. We use synchrotron technologies. We both do, but there's a lot of different interesting technologies at work. And just even if you don't have a broad background, I have to say I'm one of the only materials science PhDs I know who never took a college chemistry course. Oh, it's two of them. It's spreading. Yeah. So, and I always say that keeps me pure because I don't know anything. And so I approach chemistry with a sense of wonder and awe and confusion, which enables me to see all sorts of fantastic things that happen in the real world. But anyway, I'm just saying that whatever your background is, and you don't have to have a lot of science background, if you'd like to learn more, if you'd like to find out a few things, do a little research, get involved in a project. I have projects with 20, 30 students involved at all different levels of education. Just contact me, and we see what we can do.
Excellent, thank you. I'd like to follow up just briefly, if you talk a little bit about the opportunity for the students in your lab on this last project in green chemistry, where you're looking at that to work with designers, because you had the opportunity not just to have a scientist or a set of scientists look at a problem in that room, you also had the opportunity to talk about that problem with a group of designers. Can you talk about the value that brought to thinking about how you are going to approach and solve the problem?
It's incredibly valuable. It's back on. It's incredibly valuable, especially if you think about it. Who accredits all the engineering programs around this? It's ABET accreditation board. If you go to an engineering college, it has to be ABET accredited. And one of their objectives, their student objectives that they require, is that you have a multidisciplinary approach to engineering design, which means not that you have an electrical engineer, a mechanical engineer, and a biomedical engineer, and a computer scientist working together, but that you have end users, stakeholders. You have people involved who are going to use things later on. To get design projects together where there's a designer or someone who's in the fashion industry or any area, or even in the textile industry, that can show them what's important. And the whole point of this is determining what's important. And when you design something, you can understand the chemistry and the physics, but if that's all you understand, you're a computer. Maybe you're a very creative computer, but you're a computer. And once you start to see what's actually important about something, whether it's socially responsible design or whether it's something that can actually be used or can actually make an impact on the design industry or the fashion industry, that's what brings the real value to an education. So that's why I like to see it.
Excellent, thank you. Now, Theanne, you've had the opportunity over the last 4 years or 5 years? Creeping on 5, okay. But you've had a real opportunity to partner with not just scientists, but designers, students who are designers, students who are business leaders, and faculty who really had never set foot in a lab. And in that space, you've really created some really unique materials and designs. Could you talk a little bit about some of those projects and some of the excitement that brings to you as a scientist, and where you believe that leads us to future possibilities in materials?
Sure.
So I should say the reason that I never took a college chemistry course is because I did art history for my liberal arts degree before doing a PhD in chemical physics. So my first chemistry class was in graduate school, and it was theoretical quantum chemistry. That's where I started. So, but that said, that really speaks to this idea that there's so many different places to arrive at this intersection.
I'm a chemist, so I'm just totally chuckling at starting at that point.
Well, so that kind of is a little bit about what brought me here today. And, I am an art historian turned chemical physicist. But really, I think my unofficial biography is that I'm a delusional optimist with a deep love for nature and its processes and community. And I think that really has been a driving force that's kind of steered me through this, what seems like a strange path. So I switched from art to science because I wanted to work on renewable energy technology. So like Gary, I did my PhD out at a particle accelerator looking at how to split water with sunlight to make hydrogen as a fuel, etc. But when I was in the lab at Stanford and Columbia, everything we were doing was very exciting, but it was kind of 10 years from being scaled to commercialization. So yes, we want to power the planet with solar and hydrogen solar fuels. But as many of my students here know, now they know I'm a chemistry fraud that taught them chemistry, the next 10 years are going to determine the next 10,000. So the opportunity 5 years ago that presented itself to be a professor of science and sustainability at FIT was super exciting, because now here was a whole different set of impacts and a whole different set of conversations and a whole different space for innovation at the intersection of so many fields. That is what needs to happen to drive change and true sustainability, and following nature's processes and implementing them into place. So a lot of my lovely colleagues are here. Asta Scasier from fashion design was kind of my first major design partner when we came together and make with students in the first biodesign challenge to develop a kelp-based bio-yarn. And these were all these things that FIT is such a special place because you can just try, you can just explore, right? If your science project fails, no one's really watching. And if it's great, then it's great, right? And that is really the space that I think also is cultivated here for learning. So within that space, we were able to do we were able to daydream and see if it worked. And sometimes that's all and the right team and the right skill set and a little bit of delusional optimism is what it takes to make it work. So we have turned kelp into yarn. We have made fabric that doesn't catch on fire, bacterial leather, using Native American tanning techniques. It is water resistant, flame retardant to a 3,000 degree flame, and strong and flexible, can be machine stitched. We've made materials out of fungal mycelium grown to shape, zero waste in the production phase. And this last year, we went really out on a limb. Every year we get weirder, I think. And so this last year, we were looking for animal-free wool. This was a Stella McCartney PETA challenge for animal-free wool, and that's really hard. I mean, wool is a very, very, there's a reason, it's this ancient fiber, but it's a performance fiber. It has a strange structure, it's a very specific structure, it's coaxial layers of different proteins, and so, kind of just resynthesizing that was not going to happen with the resources we had here. So we kind of set out to say, well, if we want to make a performance protein fiber, and this is where we were tackling this big issue of microplastics, performance fibers are generally reliant on petrochemicals and animals products. Those are two of the most CO2 producing industries in the world, the most ethical issues, the biggest environmental polluters. So we thought, well, nature has this huge array of performance and function. It's absolutely fantastic, and you can never even unravel the layers. I mean, I think we here look, at least my work is really fueled by learning from nature. So we thought, nature has all these proteins that, casein from milk is naturally, you can make a waterproof textile. What if we could translate the function of the proteins that drive everything in our body and everything around us into performance fibers? Weird, right? So it turns out you can, and we did. So we took cheek swabs, extracted tubulin protein from, it's in all your cheek swabs, it's in your goldfish, it's in your Aunt Tilly, it's in a dog. And we did this with a number of different proteins, and ultimately we were able to translate this into a fiber using enzymes, which is another protein. But then we really kind of went out on a limb, and we were like, color, the dye industry is so toxic. What if we could, and then we looked to nature. So in studying the effects of the fashion industry on the ocean, coral bleaching, ocean acidification, carbon emissions, you see all that loss of amazing color. And that amazing color in the ocean and from luminescent creatures is not due to pigment or dyes or a fraction of light. It is due to a protein that gives it its color. So one of our teammates, Sebastian Kochoba from Bionimica, a self-taught biohacker, was on a diving trip, and he sampled one cell from the bleach side of a red fluorescent coral. We brought it back to the lab, and we tried to carry out our mission. We sequenced the DNA. We found the amino acid responsible for the red fluorescent protein. We were able to engineer it and express it in bacteria in the lab, make tons of it, and then we used some enzymes and actually went from a protein in one cell to a pink fluorescent fiber. And this was 3 textile development students, a strange chemical physicist, and a biohacker, right? And so, of course, there was a community supporting us. There was a community around us. We were asking questions. But this speculative future became a prototype, really over the course of about 8 weeks. And so I think this special community here and the openness for people to get out of their silos and learn from each other is really at the heart of the dynamic interactions that lead to innovations in sustainability.
Excellent, thank you. I think it's really exciting to hear all of the different perspectives on how we can really shape the future with materials using socially responsible methods that are well quantified at every step of the process, ensuring that we are in fact offering equality and social justice along the pathway to an actual product. I think that is a very important key to how we talk about fibers and materials that are shaping our future. But what I hear from all of you is that there's a huge amount of power in collaboration and not worrying so much that you were trained or prepared in a very specific way, but more being open to learning and problem solving and being curious and asking questions. Is that a fair summary of what you all really shared with us about your journeys and thinking in materials of the future? I get an affirmative yes from all of them.
I think something that is really uplifting and something that we've learned, people think, there's this idea that sustainability is really limiting, right? You can't do things to be sustainable. But I think you can prefer to think of it as expansive. Like, there's more possible protein combinations for performance fibers than stars in the galaxy. There's more things you could never have thought of. Who would have thought Native American techniques on bacterial cellulose would make a, animal-free leather with performance properties? I think it's really exciting to be at that interface, think of a real problem, address it together, and think of it as an expansive space where that creativity can take you completely outside your silo and comfort zone.
I think that's true. And as I disclosed earlier, I'm a chemist by trade. And so I look at these problems, and what I really hear is that we're using studies of properties and materials that maybe we didn't think of in the space of sustainable or biomaterials to help us inform and look back a second time at nature for additional inspiration, because we're talking about nanomaterials, optical fibers. These are things that were largely made in the lab and that were really all people in our fields were talking about, especially in the 80s and 90s. Is that fair? Mm-hmm. And today we're looking at taking these really cool things that did some really great things and provided us lots of future, especially in the communications industry. But can we use some of those techniques and what we learned in that space to inform how we make new materials that do new things that are now inspired by nature and therefore leave less of a carbon footprint?
I think that in addition to just looking at other fields and being inspired by them, one thing that I've discovered in many cases is the need to go back and look at old research. And that's actually something that students tend not to do. If a paper was written before 2010, they think, well, that's not modern anymore. But I'm learning more from stuff that was written in the 1950s, and 1940s, and before, that maybe they didn't have the tools to understand what was going on, but there's hints. there's hints in there. And so I think it's not only looking at other fields, but looking at greater depth within your own field. And I know it's a daunting task, but we certainly have the tools to work with massive amounts of data, which is a huge benefit today. I know that you're familiar with these analytical techniques now that can generate so much data that you have to use machine learning to try to find out the secrets that are hiding inside of it. And that's getting us to a point where maybe we can start to do some experiments that were hinted at a long time ago, but never really made sense because it would have taken too much effort and too long.
Excellent thing.
I think also it's important that inspiration comes from really unexpected places. So Austin and I had a moment this morning where we were like, and we shared this thought about the cotton recycling project, and there's some of these really innovative ideas that wound up working out scientifically was, I suggested one pathway, and then my student was Danny Esposito said, well, why don't we do it this way? And I was like, because you're a genius and I'm an idiot. I had this overly complicated idea of how it should be done, and she had this like super simple idea that worked really, really well. And then, we were able to characterize it together because we had the science tools. But I think staying that expansive space of open-mindedness and looking for inspiration. I loved what was said in the panel this morning, that when you're designing something, you should think about the end at the beginning. So at the beginning of your design, think about the end, because it should be a circle. So I really liked a lot of the different pieces from this conference.
There's a lot of the work going on circular economy is not in this country.
Right.
I mean, I review proposals from around the world, and the amount of this work going on in Italy right now, and South Korea, and other places. I mean, there's tremendous inspiration from there. So you have to take a very global perspective as well. I have to say that a lot of my inspiration for things to do comes from my students. I mean, they're kicking my butt all the time. They're like, I want to do this, I want to do that. Okay, I'll try to find you some money or something. I wouldn't have even touched 3D printing if I hadn't have a student show up at my lab one day from SUNY New Paltz, who I was going to have work on nanoparticles. He said, I don't want to do that. I said, what do you want? He said, well, you just got some 3D printers up here. Let's do some of that. So then all of a sudden we started doing all sorts of experiments with those and learning about them. But I like to take my cues from the students, at least, and my wife reads a lot of fashion magazines. So it's basically, she's the one who pushes me into a lot of things as well, because she reads about these things that I would never see normally. So
it's true. All the biodesign projects were student driven. I mean, the students graduate and move on and often stay working on the projects, but they're really, really student driven projects. And a lot of it is kind of like, let me find you some money or connect you to someone who knows about, it's really a support role where you have a bigger picture of what's available. But I think we should take a moment and give our students a hand, because you guys are really the drivers of the change, so thank you.